In this video, we are going to talk about development. It's not the development that is related to progress, it is a different one. It is related to development of solids. So let us discuss what development is. Let us understand it in a very easy way. Everyone loves gifts, and obviously in ancient times, everyone used to wrap the gifts themselves. Whenever you have done gift wrapping, you have noticed that you transform a square gift wrapper into the shape of the gift. That means you have just transformed a 2D sheet into a 3D object. And how did you do so? We have wrapped a 2D sheet into a 3D object by just folding it into a pattern. So basically, in engineering drawing that shows the folding or unfolding pattern is called development of a solid. Now imagine that a solid is enclosed in a wrapper of thin sheet like paper, and when this covering is opened out and laid on a plane surface, we can observe the paper is flattened, having some folds on it. This flattened out paper is the development of solid. So describing development, we can say that a development is an unfolded or unrolled 2D figure of a 3D object. Development is also called a pattern, and when the pattern is cut, it can be rolled or folded back into the original object. In the same way as chocolate wrapper can be wrapped again above chocolate to get it in its original form. Now let us understand first why we need to study development. Why is development important? Its applications have been in many places. There are many products or objects like chimneys, pressure vessels, boxes, etc., which due to their shape and size are very difficult to manufacture by conventional manufacturing process. So these products are fabricated in sheets. Then these sheets are rolled or folded to form the desired shape. This development technique has diverse use, so it's important to study about development or pattern, because patterns can give the true shape and size of each part of the object. Development can give the true area of each surface of the solid. It seems that we have understood about development of solids, but there is one tricky question left. In projection of solids, also, we can project the true shape and size of an object, like in auxiliary view. So how does development differ from projection? Don't be confused. Development is different from projection. While projection shows the true shape of one particular surface, development is a 2D plane drawing that shows the true area of every surface of the object. And development is a representation of an unfolded sheet so that no edge of the solid remains hidden. It is clearly shown in image that no edge, face of this cube remains hidden in its development, that is, in an unfolded sheet. So in development, no dotted lines are drawn like projection. This is how development differs from projection. So basically, we are going to discuss in this chapter methods of development of different regular solids, their sections and frustums. The surface of a solid, when laid as a plane surface, the shape so obtained from plane surface is called development of that solid. Like when a pyramid is laid on a sheet, then the shape obtained from the sheet will be the development of the pyramid. Now let us see how the development of the surface can be drawn. So for that, there are various methods for development of surfaces. Parallel line development, radial line development, triangulation development, approximate development. So these are the methods of development of surfaces. So this video completes the introduction to the development part and various methods of development of surfaces. So in our next video, we will discuss in depth about these methods. Different methods of development of solids. In our previous video, we got ourselves familiarized with the development of surfaces. Also, we got familiar about different methods of developing a solid. So in this video, we are going to study in depth about these methods, which are parallel line method, radial line method, triangulation method, approximate method. So let us discuss these methods one by one. Firstly, let us see parallel line development method. Parallel line development method uses parallel lines to construct the expanded pattern of the 3D object. This method divides the surface into a series of parallel lines to determine the shape of the pattern. This method is used for developing the solids in which all edges of lateral surfaces are parallel to each other. Example, prisms and single curved surfaces. In prisms and cylinders, all edges of lateral surfaces are parallel to each other, so in these solids we use parallel line development methods for developing the surfaces. Second method used for developing surfaces is the radial line development method. Radial line development method uses line radiating from the center point to construct the expanded pattern. It is used for developing those solids in which apex is taken as center and slant edges or generators of the solid are taken as the radius of the development. Basically, this method is employed for solids like pyramids and cones. In pyramids and cones, apex is taken as center and any one of the slant edges is taken as radius, and then pattern is drawn. So we use a radial line method for obtaining a pattern of pyramid and cones. Next method is triangulation development method. Triangulation development method is used for developing polyhedrons, single curved surfaces, and rapid surfaces. This method is used for developing transition pieces which are usually made to connect two different shaped objects. Basically, this method is employed for polyhedrons like tetrahedron and other transition pieces. In tetrahedron and transition pieces, triangulation development is used for their development. Then, the last method of development is approximation development. In approximation development, the pattern obtained on a plane surface is only approximate. In approximation development methods, the pattern is stretched or distorted to obtain its final shape. It is employed for double curved surfaces like spheres. As developing a sphere in 2D plane is not possible, so for developing sphere, approximate method of development is used. So basically we have studied that the approximation development pattern is distorted or stretched to obtain its final shape. And in rest 3 methods, the pattern is not distorted to obtain its true shape. Thus, we can say that parallel line development, radial line development, and triangulation development are true developments, while approximation development is, well, an approximate form of development. Because true development is one in which no stretching or distortion of surfaces occurs and every surface of development is of the same size and shape as the corresponding surface of the 3D object, like in prism, pyramid, cone, and other polyhedrons. And in approximate development, stretching and distortion of surfaces occurs in development of solid, like in the sphere. Now let us discuss the basic difference between true development and approximate development of the solid. The first difference is something that we already know. In true development, no stretching and distortion of surface occurs, while in an approximate development, there is distortion in the surface of the pattern. The resulting flat patterns in true development are of the same shape and size, while in an approximate development, the resulting flat surfaces are not of the same shape and size. True development can be used to develop solids which contain at least one edge, while an approximate development develops the solids which do not contain any edges at all. True development can develop polyhedrons and single curved surfaces like cones and cylinders because polyhedrons are composed of plane surfaces and single curved surfaces are composed of generators. On the other hand, an approximate development can develop double curved surfaces like a sphere, because spheres are not composed of any lines. This image shows the true development of a pentagonal pyramid. As we can see, it satisfies the definition of true development. The approximate development of sphere is shown in this image. This development is obtained by cutting sphere by a series of cutting planes, as its development is not possible, and the developed surface should be stretched or distorted to get its final shape, that is, sphere. So these are the major differences between true development and approximate development.